This video is going to go over the basic setup and operations of the air bearing platform. Before we begin, make sure you're wearing nitrile gloves, a face mask, safety glasses, and preferably a hat or some sort of hair covering. If you need to wipe off any surfaces, there are boxes of Kimtech dry wipes available at the front of the room. Now, I've made a few modifications to the air bearing platform since the last time you saw it. Specifically, I removed the entire propulsion assembly. Of course, with it came the propulsion electronics control board seen here. Normally, that control board is used to wirelessly relay pressure data and commands to and from the propulsion system. Since I can't remove the electronics control board from the propulsion assembly very easily, instead what I've done is hooked up an analog gauge to the low pressure side of the air bearing platform. We have the base of the platform itself, complete with a regulator and a low pressure gauge, which goes from 0 to 60 psi. We have two 9-ounce CO2 bottles, and we have all of the hookups necessary in order to hook the bottles up and secure them in place with these Velcro straps. 3 air bearings, which are in the boxes right here, will go on each of the legs here and attach to the pneumatics using these tubes here. Before we begin assembling the air bearing platform, we first need to measure how much CO2 is remaining in the bottles here, using this 5 kilogram digital scale. The bottles are each labeled with their tare weight corresponding to 18.6 and 18.7 ounces, respectively. We're using English units in this case because CO2 for paintball tanks is generally measured in ounces as well. The maximum capacity for these bottles is 9 ounces. Starting off, I'll turn the scale on. It should already be set to ounces right here, but if you need to change it for any reason, you can cycle through the units using this button here. Take the bottle, remove the yellow cap, and place the bottle on the scale. Again, this bottle's tare weight is 18.7 ounces. We're measuring 23.7 ounces. So you take the difference between those two, and you will get the amount of CO2 inside the bottle. In this case, it appears to be about 5 ounces. We'll do the same for the other bottle as well. Place it on the scale, take the difference. Again, it's approximately 5 ounces, give or take. That means these bottles are over half full. Now that we've measured the amount of CO2 in each bottle, we can go ahead and install them in the platform. Note that each bottle is labeled left and right correspondingly. Left and right corresponds to the left side of the air bearing platform and the right side of the air bearing platform when you're looking from the top down and with the gauge facing you. Therefore, the left bottle would be installed on this side, and the right bottle would be installed on this side. The installation order does not matter, but in this case, I'm just going to start with the right side. So to install the bottle, I'm going to stick it through this end here, and you'll notice that this 3D printed shape here corresponds to the diameter of the bottle. That will be used to brace the bottle against the structure of the air bearing platform and will be used to latch onto it using the Velcro braces over here. So thread the bottle in gently. It should be pretty easy until it gets close to the end, in which case you'll feel some resistance. You'll know it's threaded properly when it comes to a very dead stop, a very firm stop, and the 2 notches will be facing up. If these notches are not facing up, then you have the wrong bottle. So let's go ahead and do the same with the left side. We'll stick it in here. It should easily begin threading into this is called an air supply adapter, or ASA for short. The bottles should screw into the ASA pretty easily until the O-ring begins to slide and catch. And give it about one more turn and it should come to a complete dead stop, again with notches facing up. Now that the bottles have been threaded, it's time to secure them in place using these Velcro straps here. The plastic loop will be going underneath and around the top side of the bottle and facing out that way. What we do is, on the inside here, pass it underneath the bottle, up through the underside here. The idea is that we're trying to get this strap to cinch the bottle against this bracket here. So to do that, we need to work it underneath that structure here. Shouldn't be too difficult. Once it's up against that, go ahead and secure it as tightly as you can. Try to make sure it's perpendicular. Nice. Now the bottle's in nice and tight. We'll go ahead and do that the same way for the other bottle as well. Pass it underneath. Thread it in. And cinch. Done. Now the bottles and the entire air bearing platform itself is very secure and very rigid. This thing can support a lot of weight with this box frame, 3D printed box frame that we have here. As long as all of the pneumatics are shut off, we can hold this in any orientation that we want. So to facilitate easier installation of the air bearings, I'm going to flip the platform upside down. Now that the platform's upside down, we can install the air bearings themselves. The order doesn't matter. Any bearing can go on any corner as you'd like. However, you might note that some bearings operate a little better than others. It kind of depends on the weather, depends on the alignment of the planets. There's no guarantee. The newest bearing is labeled new bearing, and each box is labeled with the serial number of the bearing that's inside it. So when you are done, make sure you match the serial number, which is printed on the bearing, with the serial number on the box here. There we go. So with that done, pull the bearing out, give it a quick wipe with a clean Kim wipe just to get any dust off of it. Go ahead and install it by taking the hose in one hand, taking the air bearing firmly in the other, and firmly pressing them together. Once you've hit a dead stop, lightly pull back to make sure the hose doesn't slip out, then set the air bearing on the ball socket. Do the same thing for the other two. One of the things you want to try to do is make sure the air bearings lie as flat as possible without any twist in the line here. Right now I have it pretty good. Ideally, you don't want to have them crooked or any angle like that. If they're flat, they should operate a little better by not, being crooked with the surface that it's on. You want it to be as flat as possible. So right here, just give it a little twist in the line. Again, doesn't have to be perfect, but it helps. A little bit helps. Once that's done, we're ready to go. Here we have the air bearing table currently covered by its dust cloth. It's not great, it's not amazing, it doesn't completely protect it, but every little bit helps. So the first thing I want to do is remove the cloth. The next step is to wipe down the table and remove any dust using a Kim wipe. I'm going to go in even, steady strokes in the same direction, picking up at one end, putting down on the other, and going again. You'll never get it perfect. For example, there's always going to be some particulate matter on the surface itself. Try your best to get as much of it off as you can, and you can always periodically rewipe the surface if you need. But ultimately, the only solution to make it any better is to put this in a clean room environment, which we are expecting to do when we move to the Stafford building. Now that the table has been prepared, we can place the air bearing platform onto the table. To do this, I'm going to pick up the platform from each side, right here, and lift straight up and walk it over to the table. Once I get to the table, I'm going to flip the platform upside down. Now you'll note that the air bearings will hang off gently like this. What you'll need to do is hold the platform with one hand, and with the other hand, hold the air bearing in place as you set it down. Do one air bearing at a time. Done. To turn on the air bearing platform, you will need a 3/16 Allen key. The first step will be to open up the CO2 bottles on the high pressure side by using the knobs here and here. What will happen is when this valve opens, the high pressure side will become pressurized and it will stop at the regulator. The regulator is set by using the Allen key to turn this set screw here. When the set screw is out all the way like this, the regulator is completely shut off. So theoretically, after opening the bottles, you should hear no noise. There should be no gas escaping from the system. So let's go ahead and turn on the high pressure side. I will hear a brief hissing noise as the high pressure side pressurizes, but it should stop very quickly. Let's start with the right side here. And we'll do the left side now. Okay, both tanks are open. Now, I will open the regulator by using my hex key to turn the set screw here. My target is approximately 20 to 40 psi, but on some occasions I have had to go as high as 50. You should never have to go higher than 60 psi. Currently I'm at 10 psi, and there's a little movement in the platform, but it's still a lot of friction. It'll come to a stop on its own pretty quickly. So I'm going to bump this up to 20 psi. It's better. You'll note that the platform is drifting on its own. That is because there are imperfections in the table itself. Some spots are low, some spots are high, and it will tend to, at least one of the legs will tend to drift into the low spots. However, the differences are very subtle, on the order of microinches. And so, oftentimes what you'll get is this processing motion. Very slow processing back and forth between low and high spots, or just very low spots. Right now we're at 30 psi. The platform is drifting very slowly, probably because of some induced motion of my just touching it. And it's pretty sensitive. I barely have to touch it at all to get it moving. You'll note, however, that some of the bearings seem more prone to sticking than other bearings. In fact, what just happened here is it looks like there was an uphill side here and it's swinging back downhill, pivoting around this bearing here. What that tells me is that there's some debris or other frictiony force that's kind of making the bearing stick on this side. So I'm going to give it a little wiggle, maybe move it over an inch. And it's still doing it. It could be an issue with the bearing itself. It could be an issue with the table. If I rotate it 120 degrees, try to get the bearings in the same spot, albeit with different bearings. Now that bearing is not drifting. Now it appears to be pivoting around that same bearing as before. So with that in mind, it might imply that this bearing is not performing as well as the others. Whether it's a problem with the tubing, whether it's a problem with the bearing itself, it's a little hard to say at this point. Now it appears that the platform is not moving at all. If I give it a little push, off it goes. It's turning a little bit to the right, implying there might be some drag on this bearing here. Again, these performance issues are very inconsistent, and it makes it very difficult to pinpoint exactly what the problem might be. The best solution I've found up to this point is a periodic wipe down of the table with a dry Kim wipe, maybe every 3 to 5 minutes. And just check from the side to see if there's any debris on the table itself. If you let the platform run on its own with enough time, it'll steady itself out. It'll find a low energy spot and it'll tend to stay there. Now for your purposes, since you are testing a torque motor, the center of the table seems to be a pretty good spot for the air bearing platform. Once it's steadied out, it should spin, well, maybe not that easily. Seems like this bearing is still problematic. Occasionally you'll hear some dragging on the surface. That means the bearing is actually crashing into the glass. It could be an issue with the CO2 supply. I'm still at 30 psi. Just doesn't seem to be working as well as it was a moment ago. Yeah, look at that. Note the difference. After about 5 minutes of operation, it was starting out pretty well. Now it's doing terrible. One of the other techniques that I use to try to make sure performance is optimal is picking up one corner of the platform from the bearing itself and giving it a quick wipe with a clean Kim wipe. Also make sure to wipe the area around it. Look at that. It makes all the difference in the world. I'll do the same to the other two as well. Again, that was the troublesome bearing just a moment ago. Do it to the third one here. Give this area a wipe down. Well, maybe it didn't make a great difference. That bearing is sticking again. If worse comes to worse, and you still can't get decent performance out of it, go ahead and bump the pressure up a little bit. Right now I'm going to bring it up to 40 psi. As you bump up that pressure, you'll start hearing gas flowing through the system. That's gas evaporating from the tanks and flowing through the line here. Note that after about 5 minutes of operation at 30 or 40 psi, you're going to start getting condensation forming on the regulator here. In fact, the regulator is already very cold to the touch. If you run it too long, it'll turn into ice. At which point, I recommend turning off the system and letting it thaw out and returning to room temperature before operating again. "40 seems to be pretty good. Still dragging a little bit on this bearing, but not as much. When I was using the platform, I found that this corner was generally one of the flatter corners to start in. As you can see, the system came right to a stop, and I could just push it. And it works pretty well. there's no drifting, no abnormal surface qualities. So this corner, I was able to get pretty consistent results starting with. The same also went for that side over there, where the camera is mounted. Over here, however, there seems to be some issues. The bearings are starting to drag on the table, especially this bearing again. So if possible, perhaps avoid the middle of the table. Once you've had your fill of this expensive air hockey table, go ahead and shut it off. The shut-off procedure goes in the same order as the turn-on procedure. That means start with the high-pressure side and go to the low-pressure side. What we want to do is disconnect the tanks, turn off the tanks, and allow the remaining high-pressure gas in the line here to vent through the regulator and through the air bearings. This will take about 20 seconds. You'll also note that as the air is leaving the line, the air pressure on the low pressure side will actually go up. This is a property of the regulator itself. It'll go up by about 10 to 15 psi before turning off completely. Originally I had it set at 40. It's up at 55 now. It went to 60 and then drops right down. If your normal operating pressure is set anywhere higher than 40, I suggest actually backing off the regulator a little bit while it depressurizes, so that when it spikes, as it normally does, it won't go past the 60 mark on the gauge. Now that the pressure has been removed from the high pressure side and the low pressure side has been purged, go ahead and shut off the regulator by turning the set screw all the way out. Once that's done, you can take the platform off the table, bring it back to the workbench, and disconnect the rest of the parts. As before, I picked up the air bearing platform from the sides right here, and I will flip it around upside down and place it on the workbench. I like to use these little stilts here to keep the regulator from hitting the table itself. Now here we are. All you have to do is disconnect each of the 3 air bearings and put them in their respective boxes. Again, each air bearing is labeled with a serial number. So make sure you match the serial number, 301685, with the box, 301685. Before placing each air bearing in its respective box, give them one last wipe down and then gently set them in. Place the phone, close the lid of the box, set it aside. To disconnect the air bearing from the line, hold the line in one hand. Use your other 2 fingers to pinch that ring and press it against the back of your hand right there. Pinch, push the 2 ends together, push with one hand inward that way, the other hand push that way, and then pull that ring back and then separate. Now that the air bearings have been removed, we can remove the bottles themselves. So to do that, we're going to flip the platform over so it's right side up. Place it on the stilts. Undo the Velcro straps, which we put in earlier. Set them aside. And go ahead and unscrew the bottles. Again, the bottles are closed now, so it should be safe to open them up. Or more accurately, the bottles are closed and the high pressure side has been purged. To determine how much gas that little operation took, we're going to measure the bottles again afterwards. Again, this is set to ounces, started at 0. The left bottle tare weight is 18.6 ounces. We are currently at 22.9. So about 4.5 ounces remaining in there. I believe we started with 5 ounces. The right bottle, again, tare weight is 18.7. We're at 23.3. Again, about 4.5 ounces. So that little procedure, I ran it for maybe 10 minutes. Took about half an ounce of CO2 from each bottle. That's pretty sizable. That means that we could probably get maybe an hour, hour and a half, if we're lucky, if we stretch it, out of a set of bottles. So it'd be nice to have more bottles on hand. It would be even nicer if we didn't need bottles that had anti-siphon tubes installed in them. A quick note on the bottles. You'll notice these two notches right here, which point, are used to designate which way is up of the bottle. The reason orientation matters is because the bottle has an anti-siphon tube installed, which bends upward to ensure that only gas is extracted from the bottle, because CO2 is in a two-phase state when it's stored at this high pressure. It's a liquid and vapor at the same time. So we need an anti-siphon tube installed and bent upward to make sure that only vapor is extracted from the bottle. Thus, these two notches indicate which way the anti-siphon tube bends upward. This is nice to have because it means we can install the bottles flat. It means we can keep the profile of the air-bearing platform low and the center of gravity low. The downside is that the paintball industry as a whole is moving away from CO2, and so it's more and more difficult, if not impossible, to find a store that can install anti-siphon tubes for you. The bottles that were purchased here use aftermarket valves. These valves did not come with the bottles. What we needed to do is disassemble the bottles, align the valves with the ASAs here, and mark which way it was up. Then take them to a paintball store and have them install an anti-siphon tube and bend it up manually. This is a very long and arduous process, and in testing we found that we didn't actually need that low profile as much as we thought we would. There were concerns about tipping. That is probably not as big of a concern as originally thought. So, going forward, it would be nice to redesign the platform such that the bottles can be installed at an angle to ensure that only vapor is extracted from them, and so that we don't need an anti-siphon tube installed in them. Or, if we're willing to go more advanced, we can move away from CO2 entirely and use high-pressure air, which is generally stored in composite overwrapped aluminum canisters at between 2,500 and 3,500 psi, if I recall correctly. Once you have removed the bottles and you have weighed them, go ahead and put the caps back on and set the bottles back in their storage location. The storage location for the bottles is in this little cardboard box here. We keep them close to the ground so that there's no risk of them falling off the table and cracking open. Place the bottles in the box, close the lid of the box, and that's it. When you're done using the table, and when you've put away the CO2 bottles, you can go ahead and remove your safety glasses. Make sure you don't take your regular glasses with it. And you can cover the table back up. One final note. There is a CO2 meter in the lab which you can plug into any of the outlets along the strip and use to monitor CO2 levels. You shouldn't have a problem. There's not a lot of CO2 stored in those bottles relative to the volume of air in the room, but just in case, there might be local concentrations. Therefore, it might be a good idea to plug this in and place the meter somewhere near the air-bearing table. I guess that's it. Good luck. Let me know if you have any questions.